이번 주 숙제 어려웠어? 아니면 괜찮았나? 이번 주? 좀 어려운 거 커버하긴 했는데. Trigonometry. 자, 괜찮았나 보네. 자, 유닛 circle부터 해보자. 저번에 we talked about how we can use something called a unit circle to find what sine and cosine is. So the first question, what is the value of the x-coordinate of point A? We're given point A here, so this is 20 degrees, right? So A, B, C, D, E, or F. 민혁아, 너가 먼저 시작해볼래?
이거 D 했는데 D.
D?
D요 D. 코스하고 100 그거죠.
110. 그치? 아유, cosine of 110 degrees. Since we're finding the x-coordinate, xy, right? Cosine is correct, and this is 110 degrees because this is 90 degrees. So that's correct. Okay, so the second unit circle is, you have 3 points, A, B, and D. Just erase that. Okay, so we have a point A, B, and C. Yeah, A, B, and C. And we're asked, which of the following coordinates is equal to cosine of 160 degrees? And yeah, 이건 설린이가 해볼래?
Is it x coordinates of point B?
X coordinate of point B. Okay, let's see. 160 degrees is around there, so it is point B. And since we're searching for cosine, it is the x coordinate. Good job. Then let's try radians and degrees then. Let's move on quickly. Radians and degrees. So in this case, actually I'll just skip around a couple questions. 17 pi over 18. We want to change that to degrees. 민혁아, what did you get for this one?
이거 170 degrees.
170 degrees. Okay, let's just move on, try another one. Let's try 345 degrees. 설린아, 너가 해볼래, 이번에는?
1, 2, 3, 4. Is it 23 over 12 pi?
23 over 12 pi?
Yeah.
Yeah, okay. Let's just move on then. I think you guys got that too. Unit circle with radians. So this time we're doing the unit circle, but not with degrees, but with radians. A, B, C, or D? For the first question. 민혁아, what did you get? When we have point A, B, and C. And we're asked what sine of 4 pi over 5 is.
이거 Y coordinate of point A.
Y coordinate of point A. Good job. Yeah. Selena, do you want to try the second question?
Okay, is it,
Just
wait,
something.
I don't think I got
Five or
this,
six.
or is it sine? Wait, I don't think I got this one.
Okay. Let's try this one then. So it says that A is here, pi over 6. Just ignore the other points. Okay, a is pi over 6. Okay, let's think about this. Let's first find out the degree, okay? So if this is our starting point, and this is what, not 90 degrees, but we can also say that this is pi over 2 degrees, right? If we change it to radians, it's the same thing as 90 degrees. And let's see what pi over 6 plus pi over 2 is, because that's this whole angle, right? Pi over 6 over pi over 2, we want common denominators, so it's going to be pi over 6 over 3 pi over 6, which is the same as 4 pi over 6. In other words, if we simplify that, that's 2 pi over 3. So it's either going to be E or F, right? E or F because we got 2 pi over 3. So is it the x coordinate or the y coordinate? Since it's the x coordinate we're finding, it's going to be cos of 2 pi over 3. Make sense?
Yes.
Okay, let's do Pythagorean identity then. Pythagorean identity. This one I think is the hard one. This one was pretty difficult. Let's try question 3. The angle theta is located in quadrant 3 and cos of theta is negative 13 over 15. So what is sine pi? Okay, 민영아, what did you get for this one?
약간 확실하진 않는데 sine of theta equal root 56 over 15.
Over 15. Okay. Okay, let's try this one. So what do we know about the Pythagorean identity? Well, we know that it's sine squared theta plus cos squared theta, right? Equals 1. Okay, knowing that, we know what cos theta is, so we can plug that in our equation. And if we do that, we're left with sine squared theta, not equal sign, sorry, plus negative 13 over 15 squared equals 1. And if we simplify that, that's going to be sine squared theta. It's going to be, not equal sign. It's going to be 169 over 225 equals 1. So sine squared theta, we want to move this to the other side. So 1 minus 169 over 225. Or if we rewrite that, that's going to be 31, 56 over 225, right? And we want to get rid of the squared. So we put a radical over both sides, leaving sine theta is plus or minus square root of 56 over 125. can simplify that to negative square root of 56 over 15. But yeah, we need the negative there since it's in quadrant 3. Okay, let's try question number 4. The angle theta, let me erase this first actually. Okay, the angle theta is located in quadrant 4 this time, and the cosine of theta is 3 over 5. What is the value of sine of theta? Salina, what did you get for this question?
I think that sine theta equals square root negative 4 over 5.
Square root. You mean negative square root of 4? Or square
Yeah,
root
negative.
of yeah,
Negative
right. Negative square root of 4 over 5? Wait.
Yeah, I think.
Right. This?
Yeah.
Okay. Yeah, okay. So we can simplify that to negative 2 over square root of 5. And something that you will learn later is that when we simplify this into negative 2 over square root of 5, math doesn't like having radicals in the denominator. So right now we have a square root in the denominator, right? For some reason, mathematicians don't like that, or just math in general. So we have to rewrite this so that the radical isn't in the denominator. So how we rewrite that is, how do we get rid of the radical? Well, if we multiply the radical, the same radical with the radical, this is essentially 1, right? Something over something equal with each other is the same as 1 over 1. So we're not really changing the fraction. So if we multiply that to the fraction, then let's multiply that out. Negative 2 times square root of 5. And square root of 5 times square root of 5 is just going to be 5, right? Because square root of 5 times square root of 5 is the same thing as square root of 25. And 25 simplifies out to be 5. So we can rewrite it as negative 2 square root of 5 over 5. Oh, shoot. But then this is a good habit to write your answer in so that your radical isn't in the bottom. But most of the times if you write it like that, it's not going to be wrong. Or even though you write it like that, it's going to be fine. Yeah. Yeah, let's actually finish our homework from here. And what I want to cover is more trigonometry, because it's a really long topic. So today we're gonna go over the graphs of trigonometry and special angles. So special angles are more related to the previous lesson. So the homework you just did, it's more related to that, but we didn't have time, so we didn't go over it. But we're gonna roughly go over it right now. So we talked about a unit circle. And let's say I had an angle right there, and that was pi over 4 radians. Or if you're accustomed to degrees, 45 degrees, right? Just right there. So if we have a right triangle there, let's say I want to find the length of each triangle, of each side of the triangle. Well, we know that the hypotenuse is 1, so since the radius is 1, the hypotenuse, this side, has to be 1. But how can we find these sides? Well, let's think about it. we know that in a right triangle, or in any triangle, there has to be 180 degrees, right? 180 degrees or pi radians in it. So if this is 90 degrees, because this is a right triangle, that means that pi over 4 plus 90 degrees, or plus pi over 2 radians, since we're using radians, plus, let's use x, because we don't know what this is, right? Plus x, plus x. This has to equal pi. This has to equal 180 degrees. So what is x? Let's try solving for that. Pi over 4 plus pi over 2 is just going to simplify to 3 pi over 4. And we're left with plus x equals pi. If we move 3 pi over 4 to the other side, we're going to have pi minus 3 pi over 4. Pi minus 3 pi over 4 is the same thing as pi over 4. Oh, look. So x equals pi over 4. So let's look at this triangle. I'm going to redraw the right triangle over here. We have an angle here that's pi over 4. And we have another angle here that's pi over 4. Okay? Can we actually, I'll redraw it so that it's shaped like this. Hopefully you guys see this. So this is our right angle, and this is pi over 4. And this is pi over 4. Isn't this basically an isosceles triangle, right? It's an isosceles triangle. And what do we know about isosceles triangles? Well, we know that this, if the angles are the same here, then we know the sides also have to be the same. So we know that these two sides have to be the same, and we know that this side is going to be 1. This is a hypotenuse, right? This side is the same as this side right now. Okay, so let's try solving for it then, using the Pythagorean theorem. The Pythagorean theorem tells us that a squared plus b squared equals c squared. So our three sides of the triangle. In this case, it's going to be y squared plus y squared equals 1 squared. Okay, let's try solving for this. Y squared plus y squared just simplifies to 2y squared. 1 squared is just 1. Y squared equals, if we divide that 2 and get rid of it, it's going to equal half. To get rid of the squared, can do a radical on both sides, leaving y equals square root of half. Square root of half is the same as square root of 1 and square root of 2. Square root of 1 is just 1, right? Square root of 1. And remember we said we don't want radicals in the denominator. So we can multiply the radical by itself on the numerator and the denominator to get rid of it. So in the numerator, 1 times square root of 2 is just 2. And square root of 2 times square root of 2 is just going to be 2. Okay, so we found that this side, the right triangle, is square root of 2 long. Okay, so in other words, this is square root of 2 over 2, and this is square root of 2 over 2. Or we can write it as a point, square root of 2, square root of 2 over 2. So if we're asked, what is sine of pi over 4? Well, we solved for this point, right? This point here is going to be square root of 2 over square root of 2. Square root of 2 over 2 and square root of 2 over 2. So sine refers to the y coordinate of the point. So what is sine pi over 4? Well, we can just write square root of 2 over 2. So what is cos pi over 4 then? Cos of pi over 4, it's the same, right? Except it's the x coordinate. So cos of pi over 4 is square root of 2 over 2 as well. So you'll find that certain angles in the unit circle, like this pi over 4, for example, will have answers to it. Like, we'll have answers you will have to memorize. You will have to memorize the unit circle. Another angle is going to be what? Pi over 6. Pi over 6. So right triangle like that. Another angle is going to be 2 pi over 3. But these angles you have to memorize the coordinates of. You'll do that later. So that's basically what special angles are. Some special angles have already written, or you can get the answer to very easily, like sine pi over 4, square root of 2 over 2. You'll just have to memorize that. But we just went over how it works, how we get square root of 2 over 2 in this lesson. So we're gonna go over graphs now, graphs of sine and cos. Do you guys know what the graphs look like? Have you guys seen it before? Graphs of sine and cos. Okay, so if you guys haven't seen it before, graphs of sine and cos look like this. This is sine. This is sine of x. So how did this graph originate? Well, the graphs of sine and cos are really interesting graphs because they are not x and y coordinate graphs. So they're sine and time. So this is e, this is time, and this is a value, y, let's say. So what I mean by that is this dot, if this dot traveled steadily, constantly around the circle like that, you can imagine it going around, and around like that, then that's what the sine graph is modeling. See here, so right now, this point is right here, but as it goes down like that, it's going down like that, and once it reaches here, it's this point, once it reaches the bottom. And when it goes up again, this graph is going up again. We're just basically modeling a point going around a circle, because that's what sine and cos is. Cos is very similar. It's just a phase shift of sine. So instead of starting at the origin, cos starts here. It goes like that. So cos starts at the maximum, right? Instead of at the origin. That's the only difference. So, but there are some things you will need to learn about each graph of sine and cos. So we're gonna talk about those things right now. The very first thing you will have to know is the midline of sine and cos. What is a midline? It's very simple actually. So this is sine, right? In this case, you will have to know, first thing you have to know, sine is just like any other graph. So you can translate it by moving it up, moving it down. You can make it like shorter like that, or you can make it wider. It's just like any other graph, so it can also be transformed. So how we graph these is using these four things called amplitude, phase shift, period, and midline. So the first thing we're going to talk about is midline. Midline is the middle line that it passes through. It's just as simple as that. So if this is a maximum point and this is a minimum point, then it's the very middle. It's the line in between. In this case, a normal sine graph, let's say we just graphed y equals sine x, right? A normal sine graph, this is 1 and this is -1. And so if this is 1 and this is -1, what do you think the midline would be? Well, it would be at 0, right? Just right between those. So if it's at 0, then we graph, well, if we're asked what is the midline of this equation, we graph y equals 0, because this type of line that goes horizontal is y. X equals something is straight up and down like that. So where is midline in an equation? Midline is the same thing as vertical translation. If you guys remember what vertical translation is, y equals, let's say, sine x, okay? If we have this and sine x like that, and I added a 1 here, then this graph would go up 1 unit like that. So instead of the midline being 0, it's 1. This is really badly drawn, but this is really badly drawn. It would be this actually, yeah. If I add 1 here, the graph would go all the way up here. And the midline would be at 1. So the midline of any sine or cos equation, sinusoidal equation, is the end number, the end constant. So y equals a sine b of x minus h. This is going to be your equation, plus k. That is your midline, the end thing. So what about let's try amplitude. What is the amplitude? Well, the amplitude is going to be, wait, let me draw. I'll draw a center. The amplitude is very similar to the midline. So the midline is just the line that's in the middle, right? Well, the amplitude is this distance from the very maximum to the midline. It's this distance right here. So if we know the midline, it's very easy to figure out what the amplitude is, right? So if we have a normal sine graph, this is 1, this is -1 right here. And the amplitude is going to be what? This distance, so it's going to be 1. So the greater we draw this graph like that, the greater the amplitude is. For example, this would probably be like 2. Or you can figure it out this way too. This is the same thing. All of these crevices, crests, are the same distance, are the same shape. They don't, fluctuate or anything. So you can use any crevice to figure out the amplitude. So what does the amplitude look like in an equation then? So in our equation, y equals, let's take a simple equation, y equals sine x. It's our vertical shift. It's our vertical shrink or stretch. So it's y equals a times sine of x, the thing that we multiply to everything. So in this case, it's 1 times sine of x, right? Just normally sine of x, it's 1 times sine of x. That's why we have an amplitude of 1. But if we write 2 times sine of x, then this is going to go double the length like that and look much greater. So remember that what A is amplitude, right? A is amplitude so far. K is midline. Okay, we covered those two things. So we have period and phase shift next. Let's talk about period first. Period. What is a period? So remember that these sine graphs are time graphs. So they model distance over time. This is time. So what happens in a certain number of times? What happens? That's what we're modeling with period. So period is basically, if you look at these things, they repeat, right? These graphs repeat. So this line repeats, and then it happens one more time, and then it happens one more time, and then it happens once again and once again. But this shape right here, that repeats forever, this shape, just this shape. How long does it take? So let's say this was 2 seconds right here. If it took two seconds for it to go like that, then our period is 2. Simple as that. Let's say it took, let's say this whole thing, so from here to here, it took 7 seconds. We know this is 7. Well, then what is one period? Well, this is one, right? And this is another. So this what do you call it? This shape, this wave happened 2 times in 7 seconds, which means that our period is 7/2 or 3.5. That's basically what period is. We model how many times, how much of the same thing happened over a period of time. So we can also use starting from this point, right? If we knew that this was 1 second right here, and we knew that this was 3 seconds, well, we're using a different wave this time. We're starting from here. Look how we start. We go down. So the next starting point, where we stop, we're also looking for where we go down from the midline. So let's see, where do we stop? Where do we start? Oh, at this point, we're going down again, right? So we already went over 1 frequency. So from 1 to 3, let's see, that's 2 seconds. So the period is 2 seconds. It's the same thing. So how do we model period in an equation then? Let's look at our equation. Period, in this case, is going to be this b, but it's not just b. Period is 2 pi over b. So y equals sine x. Y equals sine x. There's no number before x, so it's just sine 1x, right? Sine 1x, which means that in our normal sine graph, our period, let's see, we start going up. Let's see where we go up again. Oh, this point, right? You start going up again. We see the same pattern. So our frequency ends here, which means that from here to here, it's going to be 2 pi. It's 1, right? So 2 pi over 1. That's our period, 2 pi, for a normal sine graph. 2 pi is our frequency, which means things happen the same over and over again in a period of 2 pi. So we figured out what period is then. Period is this, 2 pi over b, okay? So we have one final thing, phase shift. Phase shift. Well, we have just one variable left, right? This is phase shift. This is phase shift. Right here. Okay, let's talk about this. Phase shift is the most confusing, I'd say. Maybe not confusing, but you can get confused with sine and cos. Honestly, it doesn't matter if either one is right or wrong. I'll explain what I mean. So we said that in a normal sine graph, sine of x, the period is 2 pi, which means that half is pi, right? This is pi right here. This is pi, which means that if we look at a cos graph starts like that. And phase shift is basically horizontal translation. So if we add sine of x minus 1, then we're moving the sine graph 1 unit to the right, right? Since it's minus 1, you move 1 unit to the right. So something like this. It would look something like this. It's removing it 1 unit to the right. And vice versa, if we do plus 1, we're moving it 1 unit to the left. So it would look something like this from the normal sine graph. But let me ask you, this is pi, this is 2 pi. We know this starts at the maximum. So this must be what? Pi over 2, right? If we phase shift sine of x and we moved it, let's say, plus pi over 2. So we moved this back pi over 2 units backwards. So it looks something like this. Okay. Isn't this graph the same as a cos graph? If you look at it carefully, they both start at the maximum. And yeah, and they have the same period. They have the same midline amplitude. Nothing changed. So it's correct. You can have, this is the same thing as cos of x. It's just that it's easier to work with cos of x, right? Because it's already in the phase shifted form. So sometimes we work with sine with a phase shift, but sometimes we also work with cos. It can be the same thing. So that's why I said it's sometimes confusing. So that's what a phase shift is. And so knowing all these 4 informations, we're gonna find out how to graph, how to write an equation of sinusoidal functions. So let's say we're shown that the graph of a sinusoidal function intersects its midline at 0, 5. So intersects midline at 0, 5, and it also has a maximum point at 0.75 and 7. Right? And we're told, write the formula of the function where x is entered in radians. Okay. So sinusoidal functions, let's start by drawing this. 0.75 and 7. Well, we know that 0.75, let's say that's 1. So 0.75 might be around here if that's 7. So that's our maximum. And we also know that it intersects the midline at 0, 5. So 0, 5 is 0, 5. So that's our midline. It's our midline. What does that mean? That this graph has to look something like this. The maximum and the minimum have to be between this, right? What does that mean? Well, if this is 7 and this is 5, that means the amplitude is going to be what? Amplitude is the distance between the maximum point and the midline, right? 7 and 5. So our amplitude, we can find out, is 2. Well, our midline is given as 5. What else do we need to know to write an equation? Well, we need to know phase shift, and we need to know period. Okay, well, let's see. This is 1, and we know that, where is it? We know that this point is 0.75, and it intersects at 0.5. So if a graph starts at the origin, and it intersects it at the origin, and it goes out like that, that means it has to be a sine graph, right? Or it can also be a cos graph with a translated function. But if it starts at the origin, remember, sine graphs always start at the origin. And this is 0.5 right now, so we know that a point has to be there. If it starts at the origin, we know that it's going to be a sine graph. So knowing that, let's write down our information so far. Y equals, A is amplitude, so 2 sine, not cos, sine of, let's see, we don't know period yet. Let's leave that for now. I'll leave a blank there. And phase shift, since we determined that it's sine and we don't have a, what do you call it? And we could add a phase shift if we rewrite it as cos, but since we know that it's sine, we don't really have to write a phase shift. So we can just leave x here, and our midline is going to be plus 5 because it's plus k. So let's try to figure out what our period is. So we have a maximum here, 0.75, and we know that we start here. Okay. That means, since sine graphs always start up, it's going to look something like this. It's going to look something like this. That means that what? Let's see. Our period actually ends before it reaches 0.75, right? So if we divide this into 4 parts, 1, 2, 3, 4. Let me draw this bigger. So right now we have, so we're starting here. This is our normal period, okay. This is our normal period, and we know that this maximum is 0.75. Okay, so 5, we can divide this into 5 units, right? This unit, this section, this section, this section, and this section are all equal, right? So if you have 5 equal sections, and if we add them all up, they all reach 0.75, can we find the distance of one section, right? We can just do 0.75 divided by 5, right? What does that give us? 0.75 divided by 5 is going to be 0.15. 0.15. Okay, so we know that one section is 0.15 long. And what? We only want 4 sections, since that's our period. 1, 2, 3, 4, which means that 0.15 times 4 is going to be 0.6. So we found our period. Our period is 0.6. But let's see here. We don't want the period if we want to write it in the equation, right? We want b. So our equation is period equals 2 pi over b. So 0.6 equals 2 pi over b. So to solve for b, we just have to switch b and 0.6 like that. And that's gonna be 2 divided by 0.6. What, 10 pi over 3? Yeah. if we can rewrite that to 10 pi over 3, so we know that b is 10 pi over 3. So to write our equation, it's 2 times sine 10 pi over 3 times x plus 5. So there might be a question like, how do we know if, since we know this point exists and this point exists, how do we know that the period is only 1? It can be like this, and then reach the maximum, right? But in this case, we're finding potential equations. So this is one potential equation. There might be other equations with different periods, but right now we're gonna do this one. That was really, really complicated, but do you guys have any questions? Any questions on how to find equations based on the information we're given? No questions? Cool. So if we're also given information, we can also graph functions, right? So if we're given an equation, f of x equals, let's say, 4 sine of pi x plus 3 pi plus 2. Let's say we're given this equation. First things first, we want to change it into this form. This is going to be our staple form that we use for every trigonometric graph. Right now, we have an a, we have an a, we have a k, we have a k, but our b, we don't really have a b, right? What can we do? Well, we can factor a pi out from this, right? Pi x plus 3 pi. Can we factor a pi out? So 4 sine, and if we factor a pi out, what are we left with? Sine pi times x plus 3, right? Plus 2, like that. If we just factored a pi out. If we factor it out, do we have a b? Yeah, we do, right? This is our b, and our h is here too, right? So we have everything. We have a, b, h, and k. So can we graph the equation? Let's try. So let's start with our midline. Midline is 2. So 1, 2. That's going to be our midline. And what's our amplitude? Our amplitude is 4. So 1, 2, 4. Around super big, actually. And whatever. 4 and 1, 3, 4 bottom, right? So this is our midline, and our amplitudes go all the way from here to here. But before we graph it, oh, we do know that it's a sine. It's a sine graph. So let's say it starts, know that it starts at the origin, and it's going to reach this point 4 above the midline. It's going to go down, and it's going to go 4 below the midline. So this is 4 units. This is also 4 units. And it's going to repeat. So what other information? We haven't drawn the phase shift in the period yet. Let's start with the phase shift. Actually, let's start with the period. So period is 2 pi over b, 2 pi over b. So we have b right now. So period is going to be, in other words, 2 pi over b is pi. So our period is just going to be 2, which means that this point is going to be 2. So when we graph this, we can label these points as 1, 2, and that's what? 4, right? Yeah, that's 4, that's 3, etc. But we haven't done our phase shift yet. Plus 3 means that this graph moves 3 units to the left So 3 units to the left means that this would become 1 unit would be here. How do I draw this? 1 unit would be like that. 2 units would actually be back again like that. And 3 units would be like that again. So our final graph, if I draw it very tinily, is gonna be like that, where this point, where this point is 2, this point is 4 from here. And yeah, so on. So we have a period of 2. Let's check if this is right. This is our period of 2. So this repeats every 2 times, right? Do we have amplitude of 4? Well, if I draw this as -2 and this as 6, then we do have an amplitude of 4. This is 4. This is 4. It's not drawn to scale. Do we have a midline of 2? We start at 2, so we do have a midline of 2, and a phase drift of 3. Phase drift of 3 means that, yes, we do have a phase drift of 3 because we changed from here and moved it 3 units back, right? If we moved it 3 units back, we're basically shifting it 1 unit left because we have a period of 2. So if you have a period of 2 and you move it 2 units across, let's say, then you're going to have the same function, right? Because these graphs go on forever like that. But if you have a period of 2 in this case and move it 3 units to the left, then you're just moving it 1 unit across, basically. Any questions on how to graph it so far? No questions? Okay. Well, that's going to be it for our lesson today. Don't forget, guys, I guess this is the last Thursday, but Thursdays we're supposed to start at 4:30. It wasn't just last week. It was following every Thursday. So if you guys came in at 5, then please watch the video and see if you got the questions right for the homework. And if you missed some of the lesson, then you can look over it on YouTube and try the homework. Yeah, I'll post the homework on Classroom. And good luck, guys. That's it.
Thank you.
Thank you.
Thank you.